The level of technical skill required to get started with AI is, honestly, wildly overestimated. If you have ever used Microsoft Excel to create a table, sort data, and make a chart, then congratulations, you already have the fundamental data skills you need. Seriously. At its core, preparing data for an AI model is about getting it into a clean, organized table with rows and columns. It's about making sure your data is tidy, just like organizing your bolts and screws into labeled bins so you can find them later. Most of your time won't be spent on fancy algorithms. It will be spent on what we call data preparation or data cleaning. This is the grunt work, the part that feels very familiar to any hands-on engineer. It's about dealing with missing sensor readings, fixing typos in log files, and making sure all your units are consistent. Does this sound like high-level computer science? No. It sounds like good methodical engineering practice. It's about ensuring the quality of your input materials before you start manufacturing. This stage is the most critical part of the entire AI process, and it relies on your domain knowledge, not your coding prowess. You are the one who knows that a pressure reading of 0 is probably a sensor error, not a perfect vacuum. Now, what about the coding part? Yes, you will likely use a programming language like Python, but here's the secret. You don't need to be a Python expert. For 90% of practical engineering applications, you only need to learn a few simple commands. You'll learn how to load a data table, like opening a CSV file, how to select a few columns, and how to call a pre-built AI model from a library. Think of it like learning a few key phrases in a foreign language to order food at a restaurant. You don't need to be fluent to get a delicious meal. The AI community has built incredible libraries, like scikit-learn, that make training a model as simple as 2 or 3 lines of code. The reality is that your journey into AI will be 80% engineering problem solving and data organization, and maybe 20% simple coding. You will spend more time thinking about which data sources are reliable, and what physical factors might be influencing your system than you will writing code. The tools have become so user-friendly that the barrier to entry is no longer technical ability, but rather the curiosity to try. So, banish the image of needing to be a hacker in a dark room. The skills you need are the ones you already use: logical thinking, attention to detail, and a deep understanding of your mechanical system. So, where do you begin this journey? You don't start by trying to build an AI that redesigns an entire jet engine from scratch. That's like trying to build a custom motorcycle on your first day in the shop. You'll get overwhelmed and frustrated. The key is to start small. Look for the low-hanging fruit. The best place to start is with tasks that are repetitive, tedious, or slow. Think about the things you do every week where you find yourself saying, there has to be a better way to do this. That's your target for your first AI project. These are perfect candidates because they are often well-defined and have plenty of data available. A great example is data classification. Let's say you get hundreds of warranty claims every month, and someone has to manually read each one to categorize the type of failure. Was it a bearing, a seal, or an electrical issue? This is a perfect job for a simple AI model. You can take a few thousand past claims that have already been categorized, feed them to the model, and train it to recognize the patterns in the text. Soon, it will be able to automatically classify 95% of new claims, freeing up your time to focus on the truly complex and unusual cases. This isn't replacing an engineer, it's eliminating a boring, repetitive task. Another fantastic starting point is simple prediction. Imagine you have a test rig that runs for hours, and you have to monitor it for specific performance thresholds. You could use AI to build a simple regression model. Regression is just a fancy word for finding the line of best fit on a chart. You can feed the model real-time sensor data, temperature, pressure, vibration, and train it to predict a key performance metric a few minutes into the future. It could then alert you when it predicts the system is about to go outside its acceptable limits, allowing you to intervene proactively instead of just reacting after the fact. The most important advice is to begin with simple, explainable AI models. Don't jump straight to the complex black box neural networks. Start with things like linear regression, finding a straight-line relationship, or decision trees, which are basically creating a flowchart of if-then rules. These models are powerful, but they are also transparent. You can actually look inside and see the logic they learned. This is crucial because it allows you to use your engineering judgment to validate whether the model's logic makes physical sense. Starting small and simple builds your confidence, delivers quick wins, and teaches you the fundamentals of the process in a low-risk way. Let's use an analogy I love. Flying a plane. Modern airliners have incredibly sophisticated autopilots. The autopilot can handle takeoff, cruising, and even landing in certain conditions. It can process vast amounts of data from sensors all over the aircraft to make constant tiny adjustments, optimizing the flight path for fuel efficiency and smoothness in a way no human pilot could. But is the pilot gone? Absolutely not. The pilot is still in command. The pilot is the one who programs the destination, monitors the systems, and is ready to take manual control at a moment's notice if something unexpected happens, like a sudden storm or an air traffic control command. This is the perfect model for how an engineer should work with AI. The AI is your autopilot. It's your co-pilot. You are the captain of the project. You set the objective. You tell the AI what problem to solve and what success looks like. You are the one who curates the data, ensuring the information you feed the system is accurate and relevant. The AI can then do the heavy lifting, sifting through millions of data points, running thousands of simulations, or finding subtle correlations that might take you weeks to uncover manually. It presents you with insights, options, and predictions, but the final decision always rests with you. This relationship requires constant validation. You must never blindly trust the output of an AI model. Never. You have to treat every result with a healthy dose of professional skepticism, the same way you double-check a calculation or inspect a critical weld. Does the AI's prediction align with the laws of physics? Does its recommendation make sense based on your experience and understanding of the system? If the AI suggests a design change that seems to violate a fundamental engineering principle, your job is to question it, investigate it, and ultimately override it if it's wrong. The AI is a powerful advisor, but you are the ultimate authority. This co-pilot relationship is where the magic happens. The AI frees you from the mundane and allows you to operate at a higher level. Instead of spending your days manually plotting data points, you can spend your time evaluating 3 different design strategies that the AI has optimized for you. Instead of reacting to machine failures, you can analyze the AI's predictive maintenance alerts and plan your downtime strategically. The AI handles the what the data says, which allows you, the engineer, to focus on the so what this means for my project, and the now what action I should take. The engineer is and always will be in the driver's seat. So what does this all mean for your day-to-day work? It means you have an opportunity to build things better, faster, and smarter than ever before. Let's look at some real-world examples where mechanical engineers are already using AI as a powerful partner. In manufacturing, AI is being used for predictive maintenance. Sensors on a CNC machine feed data into a model that has learned the signature of a healthy machine. It can detect tiny changes in vibration or temperature that signal a tool is wearing out, or a motor is about to fail, alerting technicians to perform maintenance before a costly breakdown occurs. This saves time, money, and reduces waste. In the world of design and simulation, AI is a game changer. Think about finite element analysis, or FEA. A complex simulation can take hours or even days to run. Engineers are now training AI models on the results of thousands of past simulations. This new surrogate model can then predict the performance of a new design in seconds. This allows you to explore hundreds of design variations in the time it used to take to test just one. It doesn't replace FEA. You still need the detailed simulation to validate your final design, but it dramatically accelerates the early-stage exploration and optimization process, leading to more innovative and robust products. Even in materials science, AI is making a huge impact. Discovering new materials with specific properties is a slow, trial-and-error process. Now, AI models can analyze huge databases of known materials and their properties to predict the characteristics of new, undiscovered alloy combinations. This points researchers toward the most promising candidates, drastically cutting down the experimental workload. The AI isn't mixing the chemicals, but it's providing an incredibly intelligent map that shows scientists where to look for treasure. This is a partnership between computational power and human ingenuity. In the end, my message to every mechanical engineer out there is this: don't be intimidated by AI. Don't worry about the hype or the complex math. You don't need to become a different kind of professional. You just need to be a curious one. Start small. Find a simple, annoying task and see if you can use data to make it better. Think of AI as your newest apprentice. It's eager to learn. It works incredibly fast, and it can help you with the grunt work. but it needs your guidance, your experience, and your wisdom to be truly effective. This isn't about a future where robots replace engineers. It's about a future where engineers, empowered by new tools, can build a better world. Now go get your hands dirty.